Hey, this is Vaughn Vernon. Welcome to my Design Accelerator tutorial. This week, I'm discussing You Don't Know OOP. So obviously, we're going to get into object-oriented programming, but are we really doing object-oriented programming today as it was meant to be done? I'll talk about the history behind object-oriented programming and how we can make adjustments today to better reflect the ideas behind object-oriented programming. Let's dive in. Here I have an abstract example. I have class A, which has a method do this. The method do this calls out to an instance of B and tells it to do something by invoking the method do something. You can see this represented in the object diagram. An instance of A has a reference to a B, and it tells that instance of B to do something. This is a normal method invocation that we are very familiar with in object-oriented programming today. You could be forgiven for not knowing who Alan Kay is, but after watching this tutorial, you better know who Alan Kay is. Alan Kay is the inventor of the Smalltalk programming language, and he also invented the term object-oriented programming. Technically, Smalltalk was the first object-oriented programming in that it was a new name that was invented along with Smalltalk. On the other hand, Simula was actually a predecessor to Smalltalk in the sense that it had objects. So technically speaking, Smalltalk was not the first object-oriented programming language, but Alan Kay did get inspiration from the Simula programming language. I'm going to tell you some things that Alan Kay has said about object-oriented programming and what his vision was for object-oriented programming and what his vision did not include for object-oriented programming. If you enjoy my Design Accelerator tutorials and you learn some things, I invite you please to like my videos and subscribe to my channel. Alan Kay stated his primary intention for objects when he said, the big idea is messaging. What he meant is that the big idea is messaging between objects. Object-oriented programming was not intended to be focused on the classes, that is, the inside of the classes. The classes had a specific purpose, and that was acting as a template to create new objects. But the really important thing of objects was the communication using messaging between objects. Alan Kay also said, OOP to me means only messaging. So the first highlight was messaging. Secondly, local retention and protection and hiding of state process. And third, extreme late binding of all things. He added that it can be done in Smalltalk and in Lisp, and that there may be other systems in which this is possible, but I am not aware of them. So these three things are really the big ideas behind object-oriented programming. Messaging. Secondarily, local retention and protection and hiding of state process. This means that the state of an object is hidden, and any processing of the data that occurs because a message is delivered to the object is also hidden. And finally, extreme late binding of all things. Now, I'll get into this one further in a few minutes. While Alan Kay's vision for object-oriented programming in the Smalltalk programming language were initially realized, after some time, Smalltalk deviated from Alan Kay's original vision. Later, in an interview with Dr. Dobbs' Journal, Alan Kay said, the actor model retained more of what I thought were the good features of the object idea. Now, if you don't know much about the actor model, I will go into this in another episode. But the actor model is basically objects that support asynchronous messaging. There's a bit more to the actor model, but I think that's a good summary, and you can understand why then, if actors are actually objects and they do fully support messaging, and internally they manage their state and process hidden from the rest of the world, and there is a possibility of extreme late binding for actors, you can understand why he thought that the actor model retained more of what he considered the good features of the object idea. And to reinforce his thought about the actor model being more true to object-oriented programming, in his early history of Smalltalk, Alan Kay wrote, "The actor's work remained more true to the original object ideas than our Smalltalk work at PARC." PARC being Palo Alto Research Center, which was part of Xerox. It's kind of the think tank and R&D area of Xerox. Now, this final quote from Alan Kay should tell us a lot about the so-called object-oriented programming that we're doing today. In 1997, at the OOPS conference, Alan Kay gave a keynote, and there he said, in part, "Actually, I made up the term object-oriented, and I can tell you, I did not have C++ in mind." Now, when you think about the few primary object-oriented programming languages today, most of them take after C++. Not entirely. For example, I can't think of a language other than C++ right now that has the concept of a friend scope within the language. Friend scope being that you can sort of go in and tinker with the object's parts that are not available to others. Although C# kind of has that in its internal scope, that at least everything within a given assembly can access any part that is marked internal. So maybe a little bit like that. Maybe it's supposed to be exactly like that. Anyway, the idea behind object-oriented programming is much different than Java, C#, JavaScript, TypeScript, you name the languages that we have today that are very heavily based on C++. This statement by Alan Kay should tell us a lot about whether we are actually doing object-oriented programming today. All right, based on Alan Kay's statement that messaging was the big idea behind objects, this specific example here represents a message being sent from A to B. Notice that I'm representing this without the parentheses that would indicate a method invocation, such as a direct function call in C or some other imperative language. In this case, it could be any language, but we can imagine that it's Smalltalk. So what actually happens is the object A will send a message to object B, and the message is named do something. This dashed line simply represents a message being sent versus a method invocation directly from A to B in this particular example. To fulfill this message send and delivery from A to B, this is representative of how Smalltalk works. It's not exactly Smalltalk, but you'll get the idea. So A sends a message to B. In this case, notice that B doesn't have a dot in between itself and the message. That is because with Smalltalk syntax, you're simply sending the message, do something, to B, and this is the representation of that in the language. What actually happens is A sends a message, but it is picked up by the Smalltalk virtual machine, and this message selector, do something, which is marked as a symbol in Smalltalk with this hash in front of it, will be used in a dictionary, or hash table if you will, as the key to look up the actual method that will be used to dispatch onto B. So there's actually a lookup here. We find the method, and the method is then invoked on B. In Smalltalk, it is actually a method invocation, but it's indirect because the method invocation only occurs because of the matching message name. If the message name didn't match any of the methods in this table, in this dictionary or hash map, then nothing would be delivered. In fact, in Smalltalk, you would get a walkback window, which would tell you that B does not understand do something. But in this case, we do find the do something message selector, and we look up the method for that and dispatch onto B. To emphasize the importance of messaging, Alan Kay added that the only way that he has found to describe what he means about the important things about object-oriented programming was through the use of the Japanese word ma. Ma means the space between. And so when Alan Kay talks about messaging being the big idea of object-oriented programming, what he means is that the messages are what pass between objects. And what is between objects is the big deal in object-oriented programming. To be clear, Ma does not mean the space inside objects. Rather, again, it is the space between, or the space between objects where messages are passed. The idea of sending a message to an object is to get behavior to run within that object. In other words, the state and a process of some kind will run inside the object. The question is, what kind of behavior are we looking for? Here I have an example, just some pseudocode. It doesn't really matter what language it is. It's not even really a programming language. But we have here a contact service, and the contact service has a method named saveContact. Now, okay, we might consider this to be a behavior. It's a behavior, not a very good one actually, but think about this. The saveContact takes the identity of a person, a given name, a family name, a street name, a city, a state province, and a zip code or a postal code. You can see that inside this method, a person is loaded from a DAO.read person ID. Following this, the person's given name, family name, address, street, address city, address state province, and address postal code, as well as any other parameters that are passed, are set on the person using property setters, or it could be some kind of an attribute setter. Roughly the same thing. These could be set methods in a Java program, but I'm just illustrating that these are properties being set. The question is, after the DAO reads the person from its person ID, are any of these operations here actually really behaviors? You could say they're behaviors because there is a method associated with this property setter. On the other hand, aren't we just really exposing not only the state of the person object, but even the shape of the person object? We could conclude that not only is this not really behavior, but actually there's more to it than that, or perhaps less to it than that. The state is not actually hidden. The shape is not hidden, and there's actually no process to the person object itself. This is really not much different than a C struct, where the contents of the structure is completely public. There's no way to really hide information in a struct. Only by convention will a team prevent a struct from being misused and accessed over an entire system. And so at least half of, if not 3/4 or even 100% of the whole object idea is not represented here within this contact service. Even the name saveContact doesn't really tell you necessarily the behavior. What it really does is it just expresses an imperative procedural contract to perform some disk operation, such as saving to a database, and that's about all that happens here. I wouldn't really call this much of a behavior at all. Here's an example of some real behavior. We have a person's object, which is of type persons. So we have a class that is a template for person's objects. A person identified by the person ID can be connected to a contact. So we can say fluently, persons connect person ID to contact from some parameters, and we know the parameters are the given name, the family name, and a postal address, for example. So when we send this message connect, we are dispatched to the connect method on the person's object, and we use the person ID to get the person from a store, and then we tell the person to keep the contact. This is another behavior, which you can see on the person class that applies to a person object. So when we tell the person to keep the contact, we simply add the contact to the contacts within the person. If this is a duplicate, it is benign. It won't do anything because this contacts is a set collection. And after the person keeps the contact, they are persisted back to the store. So you can see the big difference here in what a behavior is versus exposing the object internals or simply setting data and persisting to a database. What about message sending, though? Is connect sent as a message with parameters to the person's object? Well, it depends on the language that you're using or even the approach. For example, if you're using Java or C#, no, it's not a message send unless you're using a specific library. For example, our open source library, actually a full platform known as Zoom, has an actor model library. And this actor model library does implement full asynchronous message sending between objects. There's also the Ruby language. The Ruby language can send messages to objects, but you specifically have to use the send method in order to send a message of, for example, type connect to a person's, and the additional parameters will be sent along with that message. But it doesn't look like this. It's actually a send method, so it looks a bit clumsy, frankly, if you use it a lot within the Ruby language. Wouldn't it be much better to have a message sending mechanism that looks and acts just like this kind of syntax for Java and C#? Well, that's exactly what Zoom, our platform, provides. That's XOOM. You can find it on kalele.io under products. I think the main point here is that even though we can't do message sending with most popular languages as they are built today, we can still have the mentality of message sending, where the important idea is to send messages between objects. We can still think of connect as being a message that is sent to persons, and connect is a true behavior, it's fluent, and this message represents the space between the person's object and the client that is sending the message to the person's object. So I think this is really the important thing to think about. Even though we don't have a true object-oriented language in the sense of Smalltalk, we can still mimic it quite a bit. The remaining topic is extreme late binding. As you recall, Alan Kay said that this was one of the important parts of the object idea. Extreme late binding is in part managed by this dictionary of message selector to method. And by looking up this message selector and finding the message, this happens at runtime. So the binding from the message send to an actual implementation of handling the message is done right at runtime, so extreme late binding. Additionally, though, because of delegation, you can actually replace the behavior through composition. So this method, when it is actually invoked, could dispatch internally to a different implementer of the same protocol. This would be similar to the state pattern, where depending on the state of an object, a different behavior is used. So that's another part of extreme late binding, and it is also a characteristic of the actor model. I'll take you through the actor model in a later episode. That's all the time I have today. This has been brought to you by my company Kalele, and you can find us on the web at kalele.io. You can also learn about my workshop, the IDDD workshop, at kalele.io/IDDD-workshop. I have a workshop coming up at the end of March 2025, also one in May and one in September that are currently planned. We have workshops often, and so you can always check this location at the website to see what's going on there. Thanks for tuning in. Again, please like and subscribe to my channel. I appreciate it very much. We'll catch you next time.